No. No, it'd be a good thing. Yeah. Here you go. Today what we want to do is we want to multiply and divide complex numbers. That's where we're going to start out. So if you have z sub 1 equal to r sub 1 times the cosine of theta sub 1 plus I sine of theta sub 1. So if you remember yesterday, that was the big deal, right? We took complex numbers and we placed them into trigonometric form, right? And I know that you completed that assignment, so that way you know exactly how to turn complex numbers into trigonometric form. Why are you laughing, Carissa? Because you didn't complete it? Oh, you're working on it right now. Okay, interesting. Well, I'll just pause my lecture. You're going to do it during Haney's class. He will kill you. All right, good thing that wasn't caught on camera. Okay, all right. Z sub 2 is equal to r sub 2 times cosine of theta sub 2 plus I sine of theta sub 2. We're like almost there. Like you get through today's lesson, Thursday's lesson, everything gets easier for the rest of the year. I'm trying to make my point. Oh, yeah. Well, this next test is super tough. But after that, it goes down one notch. Oh. Okay, here we go. Shuba Shmat. Let's do it. All right. We're getting sidetracked here. Where's this stuff? There it is. All right. The question is, suppose we want to take Z1 times Z2. What is it? Well, Z1 is this guy. Z2 is this guy. Anybody want to take a guess what I do with the radius values? Yeah, I take r sub 1 and I multiply r sub 2. That will be your new r value times the cosine of, anybody want to guess what I do with the theta values? Times them, which is incorrect. I add them. But you would have no idea. You know, it's just kind of like, well, you know, why do you do that? I don't have time to go through the proof. You can check out your book or see me after school. Yeah, so that's how we do it. Oh, see, you just got smarter. We're going to talk about that in a second. It's okay, Sam. Yep, we believe in you. All right, so let's do the first one. Z sub 1 times Z sub 2. Just draw an arrow. All right, we got 2 cosine of pi over 4 plus I sine of pi over 4, and then 5 cosine of pi over 3 plus I sine of pi over 3. I'm going to multiply these two guys together. What's your new radius value? 10. That's pretty easy, huh? Times the cosine of, what do I do the angles? Add them. What's pi over 4 plus pi over 3? 7 pi over 12. Ishika, how'd you come up with 7 pi over 12? Common denominators. So pi over 4 was 3 pi over 12. And then pi over 3 was 4 pi over 12. She added those together. She got 7 pi over 12 plus I sine of 7 pi over 12. Yeah? It will always be the case. Anytime you have a trigonometric form of complex number, these theta values are the same. By definition from yesterday. Good question. Thank you for asking. All right. Now what we have to do is we got to learn the next step, which is what happens if we divide them. So if we take z sub 1 divided by z sub 2, anybody want to guess what you do to the r values? Divide them. What do you think I do to the theta values? I subtract them, just like Logan said. Okay, So now if I want to do z sub 1 divided by z sub 2, what is my new radius value? 2/5. Cosine of, I got 4 pi or 3 pi over 12 minus 4 pi over 12. Negative pi over 12. Is that it? Come on. Somebody speak up. Can't have negatives. What do I do? Yeah, so what happens to the cosine negative? Just goes away. And then minus I sine of pi over 12. Yeah, don't leave the sine or cosine of a negative angle. We use what we call, those are even and odd identities. Those are from the back sheet. Remember us doing that. How's that? Not too bad, huh? We're going to pause it for about 3.5 minutes or so. You guys are going to try a couple problems in your assignment, and then we're going to go to the difficult stuff. Okay, Maddie and others who are not here who need to check this out. Ashley, here you go. So this brings us to DeMoivre's theorem. DeMoivre says if z is equal to r times cosine of theta plus I sine of theta, then what we also know is that z to the nth power, so DeMoivre's theorem talks about taking a complex number and raising it to power. So we just did division and multiplication, but now what if we take it to power? Anybody want to guess what we do to r? R to the nth. Nice job, Emma. Once again, always focused during class. Way to go. What do you think we do to theta? We multiply it. Remember, folks, for the last one, when we multiply them together, we multiplied the r values, but we added the theta values, right? We did one operation lower. So in this situation, if we take it to power, then we add here. So we go theta sub 1 plus theta sub 2. Whoop, no, I'm sorry. I'm sorry. Theta times n plus I sine of theta times n. Yeah? Okay. We got these 3 challenging examples. Brace yourself. Let's get ready to go. We're going to take 1/2 plus 1/2 I. We got to raise it to the 10th power. Imagine multiplying that out 10 times. It would be ridiculous. So we're going to do an easier thing. We're first going to convert it into trigonometric form, and then we're going to use DeMoivre's theorem. So I'm going to take this, convert it to a trigonometric form. This is a review from yesterday in case you missed yesterday's lesson. I got to start by finding r. What is r going to be? From yesterday, how do we find r? Square root of a squared plus b squared. 1/4 plus 1/4 is 4 plus 1/4 is 1/2, right? So that's your new r value. Everybody got that? Okay. Now I set tangent of theta equal to b divided by a. B divided by a starts with a 1. Very good. Where is tangent positive? In the first and the third quadrants. Excellent. Why are we in the first quadrant? Yep, because if you're over 1/2 and up 1/2, you're in the first quadrant. Good. Okay, so I inverse 1 on the calculator. What do I get? 45 degrees. 45 degrees turned into radians. Pi over 4. Look at how much mathematics we did just within those steps. I mean, it is absurd, isn't it? But that is the fundamentals of trigonometry right there. So here we have it. We know that z is equal to, what the heck is it? Square root of 1/2 times cosine of pi over 4 plus I sine of pi over 4. Well, what do we want to do with z? What's the whole point of this problem? We want to take the number and raise it to the 10th power. So we know that z to the 10th is equal to, what do I do with the square root of 1/2? I got to take it to the 10th. So think about this, folks. This kind of tests some of our knowledge about exponents, but I've got 1/2 to the 1/2 to the 10th power, right? You got, so it'll be 1/2 to the 5th. Yeah. So you got 1/2 to the 5th power times the cosine of, what do we do with the angle? Times by 10, and I get 10 pi over 4. I like to reduce in this step here. 10 pi over 4 is the same as 5 pi over 2. Nope, that's not the final answer. What's 1 to the 5th? 1. What's 2 to the 5th? So 1 over 32 times the cosine of 5 pi over 2 plus I sine of 5 pi over 2. You can't leave an angle if it's bigger than 2 pi. And 5 pi over 2 is definitely bigger than 2 pi. Would everybody agree that 2 pi is the same as 4 pi over 2? Everybody agree that those are the same? So watch what's happening here. This is the only time I'm going to do it, but this refers back to coterminal angles in our work there. But if you've got 5 pi over 2, that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So isn't that the same as pi over 2? 5 pi over 2 brings you the same spot as pi over 2. Agreed? So how could you actually find that? Take 5 pi over 2 and subtract off 2 pi, or 4 pi over 2. See if we subtract those. What's 5 pi over 2 minus 4 pi over 2? Just pi over 2. So we've got 1 over 32 times the cosine of pi over 2 plus I sine of pi over 2. That is what you call trigonometric form of that complex number. We need to do one more thing. We need to turn it into complex form before we're done. Can somebody tell me what the exact value of cosine of pi over 2 is? Think, folks, pi over 2 is sitting right here, and that coordinate is 0, 1. So the cosine of pi over 2 is 0, correct? That turns to 0. What's the sine of pi over 2? 1 times I would be I. So if I distribute this 1 over 32 to each of these, what's 1 over 32 times 0? And 1 over 32 times I is I over 32. So what that means is if you were to actually take 1/2 plus 1/2 I to the 10th, you take 1/2 plus 1/2 I, you were to multiply it out 10 times, what would it simplify to? It would simplify to just I over 32. I dare you to try it. I dare you to multiply it out and see if you come up. Think there's a good chance you make a mistake? I think there's a really good chance I'd make a mistake. I'm guessing it would take me at least 3 shots before I get it right, maybe 4. But look, we found it out within a matter of about 6 minutes. Somebody said last hour, I said, it's great while you do it, Mr. Gens, but I know as soon as I try this on my own, I'm not going to be able to do it. Okay, I give the person credit for being honest with themselves, but they also shortchange themselves. You guys will be able to do this, and you will be asked to do this kind of problem on your test. Are you ready to see 2 more examples so you can be successful? All right. You leaving, kid? You leaving me? Oh, just reorganizing. Okay, got it. All right. Here we go. 1 plus the root of 3i to the 20th power. Ick. I don't want to multiply this out 20 times. Instead, let's put it in trigonometric form. What is r? Square root of a squared plus b squared. What is a squared? 1 plus 3, and I get those. Very good. Let's finish for 2. So you got 2 is your r value. For theta, I do tangent of theta is equal to b over a. Yep. So Ishka remembers that tangent of 6 degrees is square root of 3. So if you inverse the square root of 3 for tangent, you do get 60. Are we in the first or third quadrant? First quadrant. So 60 degrees in the first quadrant, what is that as radians? Pi over 3. So that's my theta value. We are now ready to write it in complex form. We have 2 times the cosine of pi over 3 plus I sine of pi over 3. Z is equal to that guy. What do we want to do with Z? Take it to the 20th. So Z to the 20th is, what do I do with the 2? So it's 2 to the 20th times the cosine of 20 pi over 3 plus I sine of 20 pi over 3. Everybody agree that 20 pi over 3 is probably more than once around the circle? Definitely more than once around the circle, isn't it? So let's subtract off. 2 pi is the same as 6 pi over 3. So we take that 20 pi over 3 and we subtract off 6 pi over 3. What do you get? 14 pi over 3 minus 6 pi over 3 again. What's that? Yep. Yeah, you subtract the 6 pi over 3, you get 14. Subtract the 6 pi over 3 again, you get 8. Subtract 6 pi over 3 again, you get 2 pi over 3. So therefore, we have 2 to the 20th times the cosine of 2 pi over 3 plus I sine of 2 pi over 3. So on the test, this would be a 5-point problem. And at this point, you would have 4 of the points. You properly placed it in a trigonometric form. That is 1 plus I roots of 3 to the 20th power. But in order to get the last point, you have to properly place it into what we call complex form. And so I have 2 to the 20th times. I need the exact value for cosine of 2 pi over 3. Anybody know the terminal point for 2 pi over 3? 2 pi over 3 is 120 degrees, which leaves me a 60-degree angle right there. So what is this location? Negative 1/2. Root of 3 over 2. Good. So you get negative 1/2 plus I roots of 3 over 2. I am going to simplify this just a little bit because it works out kind of nice. Watch how this works. If I multiply this 2 to the 20th through, I get negative 2 to the 20th over 2 to the 1st plus I times 2 to the 20th roots of 3 over 2 to the 1st. Notice you have a 2 to the 20th in the numerators and a 2 to the 1st in the denominators. What's going to happen? If you have the same bases, what do you do the exponents? If I have x to the 7th over x to the 3rd, that's the same as x to the... So 2 to the 20th over 2 to the 1st is 2 to the 19th. Yep, so I have negative 2 to the 19th plus I times 2 to the 19th roots of 3. That one's kind of ugly, isn't it? And I want to be clear, with you folks. I don't want to give you an example like that. If on the test, I would accept this as complex form if you simply left it like that. I wouldn't ask you to try to go down to here, but I think that if I probably stole this problem from the book, and I think it simplifies to that. But the previous one, we went to I over 32, and that works out quite nicely, doesn't it? So I would expect you to do that. Okay. And this last one works out very nicely as well. So I've guided you through the first few. You guide me through this one. Where do I start? Square root of? Good. Good. So r is the square root of 2. Now what? Tangent theta is? So I'm in the second or the fourth quadrant. Which one am I? In the fourth quadrant. Okay. And Ishika said if I'm in the fourth quadrant and you inverse 1, she said you get 45 degrees. So what does that mean? Close. 7 pi over 4. What was the angle in degrees that you come up with for this spot? 315 degrees. That converts to 7 pi over 4. Good work. Excellent question. First of all, do you know where tangent is negative? Okay, so then you look at how you would plot the coordinate. So 1 minus I. Remember yesterday? We go over 1 and down 1. That's how we determine it's the fourth. Better? Okay, excellent. Trigonometric form. Good. So Z is root of 2 cosine of 7 pi over 4. Good work. Ooh, to the 100th. How am I going to do the square root of 2 to the 100th? 2 to the 1/2 to the 100th. Oh, good idea. Man, you guys are smart. Then what? Multiplied by 100. Okay, Ishika makes a good point here. She says that she would subtract off 8 pi over 4 over and over and over again. This would take a long time, wouldn't it? So, yeah, let's just divide. What's 700 divided by 4? So is 175 pi more than once around? Yeah. So we would have to subtract off 2 pi every time, right? So let's subtract off 2 pi and see if you can catch on with what's happening. 175 pi minus 2 pi will give you 173 pi. Subtract off again. 171 pi. Subtract it off again. 169 pi. Subtract it off again. 167 pi. Anybody know where we're going to end? Just pi. You're getting odd numbers of pi every time, right? So we'll end at 1 pi. 2 to the 50th times the cosine of pi plus I sine of pi. That is what we refer to as trigonometric form of a complex number. If you would like to do complex form, that's a little bit different, but it's no big deal for us because we are super smart. To the 50th times. Anybody know the exact value for the cosine of pi? It's -1. Okay, pause, everybody. So I need to learn from you. I asked what's the cosine of pi, and I heard 0, and I heard 1. I heard Willie say -1. Can you tell me what's happening in your brain? Are you just making guesses? Like what's happening? I need to. Are you making the circle? Are you plotting the point? So you're thinking up at 90. You're not using that pi is actually 180. Okay. Okay. All right. Okay. So when I ask that from now, I shouldn't say what's the cosine of pi. I should say pi is the same as 180, and then 180. Okay. All right. Got it. Root of 2? Well, you were the one that told me that if you take the root of 2 to the 100th power, that's 2 to the 50th, right? Have you not learned that I put a line through my Z's? Yeah, why does she even belong? All right. Okay, sine of pi. Well, not a theta value, it's 0. So plus I times 0. All right. So let's distribute that 2 to the 50th, and we get -2 to the 50th. And then 2 to the 50th times 0, I will just be 0. If you want complex form, you're going to have to distribute it. Got it? Folks, this isn't easy stuff. This is challenging. This is part of what Riverwind demands that we have as a standard to know how to prepare for what we need for college. So I'm not choosing to teach you stuff that I just think is cool. I think this is awesome. But here's what I really like about it. Have you had to access things in your brain that we've used previously in this course? Yeah, it's amazing how much it really comes up. So you have 4 problems on the back of your worksheet that are related to this. You have to work through your confusion and try those out. I believe in you. I think you can do it.